Hello, and welcome to our SOL review of A.04a, literal equations. Now, A.04a actually comes before A.4d, which is solving equations, and I actually recommend you go and watch A.4d first before watching literal equations. Some of the techniques that are talked about and introduced in that video might be more helpful before tackling this one. But let's go ahead and dive in anyway. So, a literal equation is an equation that involves multiple letters, hence the literal part with the English. So what we're focusing is on, we're trying to solve it for a different variable. So if you look in the very first problem, it's solved for C, but maybe we're solving it for A instead. And what we're going to focus in on with this is this key phrase of opposite operations. You always want to do the opposite to kind of undo something. So if I'm solving for A is on the right side of my equation. If you don't believe me, there's a little stick to kind of help show the balance of the equation, left side and right side. So C's over there. That's great. We don't really care. We want A by itself. So we need to get rid of this negative B. And the opposite of, well, subtraction is addition. So we're going to add a B to both sides. So minus B, but add B, that just cancels out. And we're going to be left with A. But the problem is C plus B, those are different variables. They don't combine. We talked about that in an earlier lesson. So what you do is you just put them next to each other. Kind of the nice part of literal equations is not as much stuff actually cleans up, so it's a little bit less work in a way. But it's harder to think about because it's a bit more abstract. Take a look here at this formula in the middle. This is actually the area of a triangle. So it's a formula we've seen for a long while, but we're going to go ahead and manipulate it. Maybe I tell you the area and the problem and the height, and you need to find the base. Well, we're going to go ahead and use opposite operations to go ahead and clear this up. Now, there's a couple ways you could actually tackle this problem. For instance, to get rid of 1/2, you can multiply by the reciprocal of 2. I don't really recommend dividing by a fraction. That never really works out. It can be messy, and it's actually improper to do that anyway. So what we're going to do, first we're going to draw a little separating bar. I'm going to go ahead and multiply both sides by 2. And I'm going to use a different color to highlight this. You'll see why in a second. So if you notice, I made sure to multiply both sides by 2, just like I added both sides to B. The whole reason is, with an equation, it's balanced. What we're saying is A is equal to everything over here. Now, visually, you're like, wait, A is just a letter. There's a number, a fraction, an ugly one at that, and a B and an H. There's so much more over here. But with an equal sign, we're saying they are the same. So we got to keep that in mind. Whatever I do over here to change, I've got to do over here as well. Now, 2 times A, that actually does clean up a little bit. It's just 2A. But over here, the 1/2 times the 2, they're going to cancel each other out. And we're going to be left with B times H. Again, solving for B in this one. And you would be told which variable you're actually solving for most of the time. There are times you'd have to use this, and maybe you kind of have to know beforehand, oh, I need to solve for Y or X. But most of the time, they'll tell you. So since jumped the gun a little bit. Since I'm solving for B, I need to divide. So the operation between B and H is multiplication. And to undo multiplication, you have to divide. Now, H divided by H cancels out. But H doesn't really clean up with anything over there, so that's actually our answer. 2A divided by H equals B. Last part. This looks like a very common equation you guys have seen. In fact, it's actually in standard form, though the equal 5 should be on this side. But nevertheless, whenever we learn to graph, we always solve for the variable y. All of our graphs have to start y equals. So why not change anything? Let's make it consistent. So we're going to go ahead and solve for y. So we always want to get rid of things on the same side that don't have the variable. For instance, 2x. I didn't say y when I said 2x. So let's get rid of it. We're going to go ahead and subtract 2x. Oh man, I'm about to run out of some room, so I'm going to write it down here a little bit. 5 minus 2x. I can't put them together because no variable, they're not the same term. So we're going to go ahead and make that 3y and move my separator over, give myself a little more room over here. All right. Now to split apart 3 times y, again, that opposite operation, we're going to divide by 3. Notice how I'm dividing everything by 3. It's just like over here. I technically multiplied everything by 2. It's just the 1/2 helped to cancel it out. With division, it doesn't really work that way, unfortunately. Now, you could leave your answer like this, the 5 minus 2x over 3. Some people might want you to clean it up a little more. So to do that, going off of what we learned a little while ago with dividing polynomials, what we're going to do is split this apart into two fractions. So we're going to end up with 5/3, and then minus 5/3, and then 2/3 x equals y. And actually, that equation's ready to graph. We got our y-intercept and we've got our slope. Let's take a look at an SOL question. All right, a formula to find the angle measures of an isosceles triangle is shown. And for the record, they love using formulas that you've seen before, so be prepared. Which equation can be used to find x? So we're solving for x, meaning what we're trying to do is isolate or separate x by himself. X is on the right side, so we're going to get rid of any term that doesn't have x, namely y. It's adding y, so we're going to do the opposite and subtract y. Now, cancels out over here. Yay, that's what we were trying to do. But 180 minus y, they're different terms, they're not the same. So we're just going to go ahead and write them next to each other like that. No harm in that. We still don't have x by itself. The problem doesn't go x equals, so we're going to split up 2 times x by dividing. We're doing that opposite operation. The 2's are going to cancel out, and we're going to end up with x by itself over here. Now we can clean this up a little bit further. So you might be saying to yourself, well, this looks really similar to one of our other problems, and I would agree. But I just want to make sure to see if we can clean it up a bit further. So let's see. I'm going to split them up. So 180 divided by 2, that would be 90. Now, we can't really clean that up, so y over 2 would equal x. So when I look over here, I have the 90 part, but it's just minus y, so it's not C. D had an addition sign. And we're actually going to back up a step and see, oh look, there it was. We actually had it when we solved it for x. So the answer was A. Thanks for watching.